Hello friends, welcome to CSC Core Concepts in a series of computer networks. In this video, we are going to understand two very popular error detection techniques, that is the checksum method and the cyclic redundancy check. So the first is the checksum method where let us understand about it. So here it is basically an error detection method which divides the data into equal size segments, and we use the ones complement approach to calculate the sum of those segments. Then this sum is delivered to the receiver side, where again the receiver repeats the same process to confirm that the data sent by the sender is same as what received by the receiver. Let us see the operations of the checksum process on the sender side. Let us say, for example, I have a continuous bit stream of data and I wish to divide the data into 4 parts. So each of m bits. So let us say here I am dividing into 4. So my k is equals to 4, and in each partition I have 8 bit of data. So m is equal to 8. Now I am going to add all this data one by one using the ones complement form so as to get the checksum. So let us see the first two data, that is the first one and the second one. We are going to use both of them, that is first this is added to this one, the sum will be added to the third segment, and the sum will be added to the fourth segment. So the addition of first two results in one carry bit. Now since we are using the ones complement form, this carry bit will be added to the result, and this is what we are getting after adding the first two segment of the data. Now we are going to add to this the third segment where we did not encounter any carry bit, and so we will continue this step with adding the fourth one. So this is the result what we are getting. Again one carry bit we are getting here, so we are going to add. So this is the final answer of the addition of all the 4 segments. Now we are going to, this is called the sum, and we are going to take the first complement of it, that is we are going to complement this number, and this is what we get complementing. What is complementing? That is reversing 1 to 0 and 0 to 1. So wherever it was 0 it will become 1, and wherever it is 1 it will become 0. So this value is called as the checksum. Now this checksum is appended at the end of the data on the while transmission. So these 4 segments were my original data, and this is the checksum which has been generated on the sender side, which is appended at the end of the data, and this complete series is sent to the receiver. Now at the receiver side, the receiver receives 5 segments, which again it is going to perform an addition, that is the first, second, third and fourth and fifth will be added. If there is a 1 carry bit, then it will be added to the sum, and then again we are going to take the complement. So let me demonstrate. This is the first 2 segments which are being added, and here we are getting a carry bit. So this carry bit will be added to the result and we get the final answer. So with this we are adding the third segment, which we are getting this answer, and with this we are adding the fourth one, which we are getting this answer with the carry bit, and hence this carry bit will be added over here, and this is the total sum. Now this time we have 5 segments since we have the checksum appended. So this is the checksum which is added to the sum to get an answer. Now this is the final answer which we are getting by adding all the 5 segments, and this will be complemented to 0. If we take the complement of this number, it is all 0. Now if you get the sum as 0, that means you can assume that you can accept the data and there is no problem. Now in case if any one bit gets changed, let us assume that one bit during the transmission it got changed, right? So let us take one example that this bit got changed to 1. Okay, so what will happen here in this addition, when you are adding finally, like here, this has become 1, right? The last one became 1. So this is the answer 1, right? And because you are adding it 1, the answer is not going to be same. Since this answer is not going to be same, you are, even by adding this checksum, you will not get a total 1 answer. You will get somewhere 0, which you complement, you will get 1. So if you get a non-zero result, that means you will understand that it is a case of error. Okay, so if there are no errors, your final complement of the answer will be totally 0. Another popular approach of detecting the error is the CRC approach, that is called as the cyclic redundancy check. Here, the check represents the data verification and the term redundancy refers to recheck. So we are going to recheck it again using the algorithmic formula. Now, same as checksum approach, this approach is also performed on both the sides, that is on the sender as well as on the receiver side, and CRC applies a CRC generator and a CRC checker at the receiver end, and sender and the receiver end. That is, at the sender end, we apply the CRC generator, which will apply the cyclic redundancy check, and on the receiver side, we apply the CRC checker, which will check. So let us see how it is performed. So it is basically performed using the value of the polynomial coefficients, which is converted in a binary format. So let us assume that this is my polynomial x square plus x plus 1. So if I want to take the binary value of it, it is 1, 1, 1. What does it mean? This is 1. Now this x is multiplied by 1. This x square is multiplied by 1. So all the three positions are 1, 1, 1. But if it is x square plus 1, it is 101 because this is the first one. Now there is no term of x, single x, okay, x to the power 1. So that means it is 0, and this is x square, it is multiplied by 1. So let us see on the sender side how the CRC generator works. So the first step is to add the number of zeros to the data to be sent using k minus 1. What is k? K is the number of bits you obtain through the polynomial equation. Let us assume that this is the data which is to be sent and this is the polynomial equation which I have to consider. X cube plus x square plus 1. So if I want to convert this into binary, it will be 1. There is no term of x raised to the power 1, so it will be 0. Then 1 and 1 for x square and x cube. Now how many total bits are there? That is 4 bits. So 4 minus 1, 3. So length of the polynomial is 3 minus 1, that is 3. So 3 zeros have to be appended at the end of the data. So initially these bits are your data and you have appended 3 0. Now next is that we have to apply a binary division method by applying the XOR and obtaining the remainder from the division. Now we have, this is our data appended with the zeros and this is our polynomial binary form. So if I am performing a binary division, that is raised to 1, okay, this is the output, then again 1. So if I perform a binary division, you get a remainder, right? Now this remainder has to be appended at the end of the data. This was the remainder. So you are going to remove the 3 zeros and instead of those 3 zeros, you are going to put the remainder and this data will be sent to the receiver. The original data and suffixed by the remainder got after performing the binary division. And at the receiver side, again, the receiver will perform a similar binary division. But this time not with 0, but the data which has been sent by the sender, which is appended with the remainder by the polynomial binary format. And if you get the remainder after performing the division 0, then you understand that there has been no change in the data and the data has to be accepted. But in case if you get a non-zero type of a remainder, then you have to understand that there is some error in the data and here there is no way to correct the error. So you have to tell the sender to resend the data. So I hope you understood these two very popular techniques, that is the checksum method and the CRC method to detect the errors. In my upcoming video, I am going to discuss about a new technique, that is Hamming code, where we are going to understand that how does it detect the error and also it corrects the error. It will tell you exactly the position where the error has occurred. So please stay tuned to this channel and don't forget to like, share and subscribe to CSC Core Concepts. Thank you.